Have you ever found yourself sitting in a meeting? You're maybe 28 minutes into a 30-minute meeting. There are three other people in the room with you,
Oh, yeah. We've all been there.
right? And heads are nodding, people are making these agreeable noises, and you suddenly realize, uh, we just burned 2 hours of collective human life, and I honestly don't think we actually decided a single thing.
Yeah, not one concrete decision.
Exactly. It's like we've all been trapped in that exact scenario, just watching the organizational oxygen quietly leave the room while everyone, sort of pretends we're engaged in this high-level collaboration.
It is entirely the phantom menace of modern knowledge work, I mean, truly. Because if you do the organizational math on that room, so you've
Mhm.
got 4 engineers, perhaps a product manager, 30 minutes of blocked calendar time.
Plus the context switching.
Yes, the
Yeah.
context switching cost to even attend the meeting in the first place. You are looking at, honestly, hundreds of dollars of corporate resources just vaporized into the ether. And it produces nothing but this vague sense of mutual exhaustion.
100%.
hmm
And that invisible drain on our cognitive bandwidth is exactly what we are dismantling today on this deep dive.
I am so excited for this one.
Same here. So our source material today is this phenomenal text titled Durable Engineering: A Field Guide to Modern Team Practices. And I want to be clear up front, this isn't just another agile manifesto or some list of quick productivity hacks.
No, not at all.
It's actually this rigorous dissection of organizational physics. It really looks at how highly proficient software teams construct systems that can actually survive the inherent chaos of, well, human collaboration.
Right, because humans are messy.
Very messy. So today we're going to explore the underlying philosophy of time allocation.
Right.
We're going to learn a whole new diagnostic vocabulary for workplace friction and discover these precise architectural artifacts needed to build resilient systems.
And I think what's so refreshing about this deep dive is that we are really approaching this text with a beginner's mind.
Oh, absolutely.
Like, neither of us are coming in here claiming to be the ultimate tech gurus who have it all figured out. We were both reading this and just having these massive aha moments.
Yeah, just constantly messaging each other like, wait, this explains so much.
Exactly, because the author grounds this entire methodology in 3 deeply humbling observations about human nature. And before we can even try to fix how a team works, we have to kind of strip away the illusions about why our current defaults fail so reliably.
Right. Okay, let's unpack this because the first observation targets that exact meeting scenario I just described at the start. It's this profound difference between actual rigorous analysis and what the text hilariously but accurately identifies as vibes.
I love that they use the word vibes in a technical field guide.
It's so perfect
Yeah.
because the text points out that a 4-person 30-minute meeting is 2 hours of work lost.
hmm
But the counter metric is what really, I think, drives the point home.
Right, the written text.
Yeah, the same information conveyed in a 10-minute written document costs exactly 10 minutes to create. And, crucial point here, it possesses permanence. It's still there a quarter from now.
Which is huge when a new engineer onboards or, when the original author inevitably forgets their own rationale.
Which happens constantly. But the psychological trap of the meeting format, according to the text, is that it actively rewards consensus over clarity.
Yeah, what's fascinating here is how in a room, as long as everyone is generally nodding, we all feel this dopamine hit of productivity.
We feel like we did something.
Exactly. The author argues that meetings allow these incredibly vague vibes to basically masquerade as rigorous thoughts. So a developer can sit there and suggest making an interface more robust or the data pipeline more scalable.
And everyone just nods.
Right, everyone nods because those are universally positive adjectives. Nobody's anti-scalable. But
Yeah.
they're just vibes. They lack any actual architectural substance.
It is this deceptive comfort of verbal agreement. You walk out thinking you have a solid plan, but you actually just have a shared illusion of a plan.
Yeah, a shared illusion is the perfect way to put it.
Whereas writing, and I love this analogy from the text, writing functions as a lie detector test for your own brain.
It really does.
If you sit down to draft just one paragraph explaining exactly how a system should be scalable, you hit a wall the very second your logic has a gap. Writing forces you to confront your own ambiguity. It demands actual structure.
And that structural demand, that's the whole foundation of an asynchronous first culture. The text advocates defaulting to writing, not because it's faster in the moment. I mean, it often isn't faster to write it out.
Right, talking feels faster.
Exactly. But we default to writing because it prevents the propagation of flawed assumptions. Synchronous communication, like meetings or calls, should be treated as a highly expensive, really scarce resource.
So wait, reading this with a beginner's mind, if meetings are bad and text is good, are they saying we should just never talk to our coworkers ever again? Because that sounds pretty bleak.
Oh, no, definitely not. And I had that same initial reaction. But the text makes a crucial distinction. It's async first, not async only.
Okay, that makes sense.
Synchronous communication is totally justified when you are dealing with deep ambiguity or, complex emotional negotiations or rapid ideation where the feedback loop really needs to be instantaneous.
So a quick 15-minute call to unlock a really thorny issue.
Great. Perfect use of sync time.
But a 90-minute call for 8 people to review a one-page document together.
Banned. Completely banned.
I love that. Okay, so if writing is our main defense against ambiguity, the second foundational observation is basically the defense against our own biology.
Oh, this one hit hard.
It really did.
Yeah.
Human memory is fundamentally, spectacularly terrible. We treat our brains like they're persistent storage, like a hard drive, when they actually function much more like volatile RAM.
Yes, volatile RAM is the perfect analogy.
The moment a project concludes, all that intricate scaffolding of context we built up in our heads, it just immediately begins to decay.
And the organizational consequence of that biological reality is what the text calls relitigation.
Relitigation, right.
If a crucial architectural decision lives exclusively in the minds of 2 senior engineers, or, God forbid, it's buried in an ephemeral Slack thread from 8 months ago.
Good luck finding that.
Exactly. The team is absolutely destined to reevaluate it. A new variable will be introduced, someone is going to question the original approach, and without the documented rationale, the team just has to start from zero.
And the real tragedy of relitigation is the rolling, invisible cost of that compounded waste. You aren't just spending time making the decision a second time.
Right, you are actively invalidating all the intellectual labor that went into the first iteration.
Teams that suffer from high rates of relitigation, they often feel like they are just sprinting on a treadmill. The velocity metrics might even look great. The Jira tickets are moving across the board.
But the actual product advancement is stagnant.
Yes, because they just keep circling back to resolve already solved problems.
Which brings us to the third foundational observation, which focuses on the physical mechanics of collaboration itself. The text identifies handoffs as the absolute danger zone in any engineering lifecycle.
The danger zone.
The exact moment a piece of work transitions from one person to another, say, from person A doing design to person B doing front end, that is the precise moment when context, obvious assumptions, and value are lost.
It makes so much sense when you think about it from an information theory perspective. A handoff is a transmission event, right? And every transmission introduces noise.
Every single one.
The assumptions that were completely implicit and obvious to the back-end engineer are totally invisible to the front-end engineer who is picking up the API.
But so, if handoffs are dangerous and synchronous meetings are wildly expensive, it does feel a bit like we're backed into a corner here. Like total isolation isn't viable for complex software.
Right. We still have to build things together.
Exactly. And the text says the solution isn't isolation. The solution is the structural minimization of dependencies.
So making those handoffs safer.
Yes. Modern team practices aim to make those necessary handoffs incredibly cheap and highly reliable. And you achieve that by shifting from synchronous coordination to durable, asynchronous artifacts.
So you build an environment where an engineer can pick up a component, completely understand its boundaries, and integrate it without needing to tap the original author on the shoulder.
Precisely. But making that transition, it requires a complete overhaul of how we discuss our workflows, because we can't fix what we can't name.
Right, which leads us perfectly into the second major section of this deep dive. The field guide provides this highly specific diagnostic vocabulary, and it starts with a really radical reevaluation of time itself.
Time is everything in this model.
We all understand the basic idea of sync versus async, but the text really dives into the brutal mathematics of context switching.
Oh, this part blew my mind. The whole concept of the quick question is just completely dismantled here.
Completely destroyed.
A simple chat message asking for clarification, right? It might take the sender 15 seconds to type. So the sender perceives the cost of that interaction as just 15 seconds.
Which feels like nothing.
Right. But for the recipient, who is deep in a complex state of flow, they're holding multiple variables, architecture paths, logic trees, all in their working memory.
It's a house of cards in their brain.
Exactly. That 15-second interruption completely shatters their cognitive state. And the text notes that rebuilding that state takes 10 to 20 minutes of focus time.
It is a completely asymmetrical transaction. The sender gets this cheap, fast answer, but the recipient pays a massive cognitive
A
tax.
massive tax.
When you multiply that tax by 10 interruptions a day, you have effectively destroyed an engineer's ability to engage in any deep work whatsoever.
This is why the async first approach fundamentally respects focus time. You log the question in the designated channel or doc, and the recipient addresses it during their natural transition periods, not in the middle of a flow state.
And controlling that flow of work requires understanding your constraints. The text leans super heavily on the concept of the bottleneck.
Which is pulled straight from systems theory.
Right. And as someone reading this with a beginner's mind, this was a huge revelation for me. The idea that in any pipeline, there is always one single step that dictates the maximum throughput of the entire system.
Yes, the slowest step determines the speed of the whole team.
So if your code review process consistently waits 3 days for the principal engineer to sign off, that engineer is the bottleneck.
And here is the truly counterintuitive reality that the text points out. Optimizing anything else in the system is just an illusion of progress.
Wait, say more about that because that took me a minute to wrap my head around.
Sure. So if you speed up feature development, like your coders are writing code twice as fast, but that principal engineer is still the bottleneck for reviews,
Yeah.
you aren't actually shipping faster.
You're just piling up code.
Exactly. You are just accumulating inventory, in this case, unmerged pull requests right in front of the bottleneck. And that inventory rots.
It gets merge conflicts, the context decays.
It ultimately creates more work for everyone. Identifying the bottleneck is the only way to apply targeted leverage.
So you either elevate the bottleneck by adding capacity, like empowering other engineers to approve certain PRs.
Right. Or you subordinate the rest of the system to that constraint, making sure that principal engineer is only working on the absolute highest value reviews and nothing else.
So that's how we diagnose time. But we also need clarity when diagnosing memory failures within the system. We talked about relitigation, which the text calls the cardinal sin of engineering.
The cardinal sin, yes.
But the symptom of it is so insidious, you don't always notice it's happening. You just notice everything feels sluggish.
Right. And to audit team health, the text introduces the metric of the SSOT, the single source of truth.
Oh man, this one hits close to home for anyone who's used corporate wikis.
Right. If an engineer has to ask, hey, which version is current? Is it the Confluence page, the GitHub README, or this random Google Doc? If they have to ask that, you do not have a single source of truth.
You've already failed.
You failed because multiple sources of truth will inevitably drift out of sync.
And once an engineer follows outdated documentation, and let's say they lose a whole day of work because of it, trust in the entire documentation ecosystem just collapses.
They stop reading entirely.
Exactly. They revert back to synchronous interruptions, just tapping people on the shoulder, because the written artifacts are no longer reliable.
And that decay of institutional knowledge leads us directly to the bus factor.
I love this term. It's slightly morbid, but it is such an effective heuristic.
It really paints a picture.
It asks, quite literally, how many individuals on your team can be hit by a bus or, more realistically, recruited by a competitor before the project dies.
Right, before everything grinds to a halt.
A bus factor of 1 is an absolute disaster waiting to happen.
But the crazy part is how often companies actually reward the bus factor of 1.
Oh, for sure. They treat them like rock stars.
Exactly. They view that individual as the indispensable hero, the 10x engineer who holds the entire complex architecture in their head.
But from a systems engineering perspective, that person is literally just a single point of failure.
A glaring vulnerability. A resilient team actively engineers a higher bus factor. They force knowledge transfer, they require extensive documentation, and they deliberately rotate domain responsibilities so nobody is the single silo of knowledge.
Moving from team dynamics to the actual code base itself, the field guide provides this excellent breakdown of two terms that are so frequently conflated: tech debt versus refactoring.
Oh, this distinction is so critical because they require completely different management strategies.
And the text uses this brilliant culinary analogy that I think scales perfectly. So refactoring is like cleaning up the kitchen and sharpening the knives without changing the actual recipe or the menu.
Right, you're altering the internal structure of the code to make it cleaner, more legible, easier to maintain, but you aren't changing its external behavior at all.
Refactoring is basically just an ongoing maintenance tax. It's doing the dishes.
Yes. Whereas tech debt, conversely, is a strategic choice to take a shortcut.
It's choosing to leave the dishes in the sink because you have a VIP customer sitting in the dining room demanding their meal right now.
Exactly. And taking on that debt is a particularly valid business decision sometimes.
Right, taking some debt to ship a feature and capture market share is okay.
The issue arises when engineering teams fail to explain the concept of compounding interest to product managers.
Oh, the compounding interest is brutal.
It is, because if you never dedicate any sprint capacity to paying down the principal of that tech debt, the interest eventually consumes your entire bandwidth.
Features that should take 3 days suddenly take 3 weeks because the engineers are just navigating this labyrinth of fragile, duct-taped workarounds. It just grinds the team to a halt.
But that strategic borrowing only makes sense if you actually have a defined finish line.
Which brings us to the definition of done.
Right. You cannot intelligently incur tech debt if you don't even know what you are trying to ship. This is where the text emphasizes the absolute necessity of a strict definition of done and defining that 1.0 or MVP.
MVP being minimum viable product.
Yes, because done cannot be a feeling.
I feel like it's mostly done.
That phrase is the absolute death knell of a sprint. The definition of done must be written: checkable conditions. Do the unit tests pass? Is the documentation updated? Is it deployed to staging?
Without those binary checkable states, work just lingers in this perpetual twilight zone of almost finished.
And lack of rigorous scope makes a team incredibly vulnerable to the psychological traps outlined in the next section of the guide.
Yes. Section 3. This is my favorite part to read. The text calls it the zoo of dysfunctions.
It is a fascinating look at the behavioral economics of software teams.
Because when scope is ambiguous and boundaries are weak, it turns out intelligent people will invent incredibly creative ways to avoid doing the actual hard work. The industry actually had to invent hilarious names for these very serious failure modes.
Starting with the most famous one, bike shedding.
Bike shedding. So I eagerly want to explain the origin of this term from the text because it is just too good.
Go for it.
So it comes from Parkinson's law of triviality. It describes this hypothetical committee that is tasked with approving the plans for a massive nuclear power plant.
A very complex task.
Right. And they approve the complex, highly dangerous nuclear reactor in about 5 minutes with practically zero debate.
Naturally.
But then they move on to the next agenda item, and they spend an hour arguing fiercely over what color to paint the employee bike shed in the parking lot.
It's so absurd, but it's so true. And if we connect this to the bigger picture, the underlying mechanism there is simply human nature avoiding deep ambiguity.
We hate ambiguity.
We despise it. The nuclear reactor is mathematically complex. Most committee members don't possess the expertise to meaningfully critique it, and honestly, they fear looking foolish if they try.
So they stay quiet.
Right. But the bike shed, that is trivial. Everyone understands color. Everyone can have a very strong subjective opinion on color without any risk of being objectively wrong.
So we funnel our intellectual energy into trivial details to simulate productivity. We debate the color of the shed while skipping the hard decisions.
Exactly. In a software context, this manifests as a team spending 3 days arguing over the naming convention of a variable while completely ignoring the fact that the underlying database schema is totally broken.
The fix for bike shedding, the text says, is time boxing. You have a leader who recognizes it, separates the cosmetic decisions from the architectural ones, and forces the team back into the uncomfortable ambiguity of the hard problems.
Time boxing is essential there. And closely related to bike shedding is another fantastic term, yak shaving.
Yak shaving. This perfectly describes my own worst habits. I was reading this just nodding in shame.
Oh, we all do it.
So while bike shedding is like a group dynamic, yak shaving is a highly individual trap. It's a series of small, tangential tasks that you convince yourself are required to do the main task.
Right. To do X, I need to do Y. But to do Y, I first need Z.
Exactly. The example in the text is so funny. You set out to fix a simple bug in the UI. But to do that, you decide you need to update a specific library.
Okay, seems reasonable.
But updating that library requires a newer version of the package manager. And the new package manager requires a different operating system environment.
And suddenly,
4 hours later, you are recompiling the entire Linux kernel just so you can change one CSS hex code. You are, metaphorically, shaving a yak.
the insidious nature of yak shaving is that every single individual step feels entirely logical in the moment.
It feels like work.
Yes. You are actively solving problems, so it creates this illusion of forward momentum, but you have completely lost the forest for the trees.
What was the cure?
The text advises engineers to build an internal circuit breaker. After the third nested dependency, the third, if I just fix this one thing, you have to physically stop and ask yourself, is the path I am on still generating a return on investment?
Or is there a less elegant, but much faster way to just solve the original problem without shaving the yak?
Exactly. Sometimes the hacky fix is the right fix if it keeps you out of the yak enclosure.
That's great advice. Now, zooming out from those individual behaviors back to project management, we hit the dysfunction of scope creep and what the text calls the 80% graveyard.
Ah, the graveyard. This is driven by the tendency for work to just naturally grow. It's driven by the four most dangerous words in engineering.
While we're at it.
While we're at it, yes. We're rebuilding the authentication flow, so while we're at it, let's also implement biometric logins.
Sounds so innocent.
It does, but it's a symptom of the sunk cost fallacy mixed with just unwarranted optimism. It expands the perimeter of the project iteratively, which ensures the finish line is always moving just out of reach.
And the inevitable result of that is the 80% graveyard. It's this portfolio of multiple projects that are all, mostly done, but nothing is actually shipped.
And here's the brutal truth. A team with 5 projects at 80% completion has delivered exactly 0 value to the end user.
0. So the expert cure for this, according to the text, is simple, but apparently very painful. WIP limits.
Work in progress limits.
Right. You place a hard mathematical cap on the number of active tasks. If the WIP limit is 3, and your team has 3 items in progress, you are strictly forbidden from pulling a new ticket from the backlog until one of those active items is actually finished.
And enforcing WIP limits causes immense psychological friction at first.
Because we want to stay busy.
Right. Highly motivated engineers hate being blocked. If they are waiting on a review for their active ticket, their immediate instinct is to pull a new ticket to stay busy.
But WIP limits force them to direct that energy toward clearing the blockage. Like go review someone else's code or pair program to fix a pipeline instead of just piling up more incomplete inventory.
Finishing matters exponentially more than starting. That is the core mantra.
Which leads us to the final dysfunction. And this might be the most celebrated but also the most toxic one. The hero pattern.
Oh, the hero pattern?
We've all seen this. The sprint is failing. The deadline is Friday. And one person works heroic hours, pulls 3 all-nighters, and single-handedly saves the project.
And management applauds, maybe bonuses are distributed, and the behavior is culturally reinforced as the ultimate ideal.
But the text warns that this actually breaks the team long-term. Why is that?
The author explicitly categorizes the hero pattern as systemic self-sabotage. Because when the hero works those crazy hours and circumvents all the normal processes, ignoring test coverage, bypassing reviews just to ship on time, they are injecting massive amounts of volatile tech debt into the system.
And the hero inevitably burns out.
They burn out, and worse, the rest of the team becomes entirely dependent on them. While the hero is off writing the whole module alone in the dark, the junior and mid-level engineers are sidelined.
They lose the chance to learn.
Exactly. The bus factor consolidates into one exhausted individual. So the text advice here is radical, and it requires real management courage. Refuse the hero gambit.
Even if it means missing a deadline.
Yes. When a project is off track, you do not activate the hero. You reduce the scope or you delay the launch. Ship less if you have to, but preserve the integrity of the team.
Wow. Okay, so we know our memories fail, we know meetings can devolve into vibes, and we know these dysfunctions like re-litigation and the hero pattern destroy teams. So what is the physical cure?
This is where we get into Section 4, artifacts.
Artifacts, the written residue that survives the conversation.
Yes, and the guiding philosophy here is ruthless minimalism. The less is more philosophy.
Which was such a relief to read. You do not need a massive wiki with 60 beautiful, colorful templates. The text says you only need 4.
Just 4 specific types of artifacts to operate effectively. Anything beyond these 4 is likely administrative bloat.
Let's go through them. Artifact number 1, the ADR, the Architecture Decision Record.
This is arguably the most important one. The ADR is a surgically precise tool designed specifically to eradicate relitigation.
It's just a 1-page dated document that captures a single decision. The format is super simple: title, status, context, decision, and consequences.
And the context section is really where the value lies. You document the landscape at the exact moment the decision was made. What alternatives did you evaluate and reject?
Right, like why did we choose a Postgres database over a NoSQL solution?
Exactly. When you document the alternative you rejected, you prove that the decision was rigorous, not just arbitrary vibes.
And the consequences section forces you to admit the trade-offs, because every technical choice has a downside.
Oh, always.
So what does this all mean in practice? It means the next time someone asks, wait, why did we do this? You don't have a 30-minute meeting. You just point them to ADR 007. 5 minutes saved in that moment becomes 5 hours saved over a quarter.
It's compounding interest, but working in your favor this time.
Exactly. Artifact number 2 is the PR or pull request description.
Right. And the text reframes code review entirely here. A PR explains what changed and why. Code review shouldn't be a rubber stamp or some pedantic argument over syntax formatting.
The text calls it a small, sustained conversation about quality. I love that phrasing.
It's beautiful because the code itself explains what was changed, but only the human author can explain why the business logic required that specific change. When you write good PR descriptions, your Git history becomes a searchable knowledge base.
Artifact number 3, the postmortem.
The blameless postmortem.
Yes, the word blameless is so heavily emphasized. This is a written analysis of a failure, like a system outage or a bug.
And the expert analysis here hinges on defeating the fundamental attribution error. Human nature defaults to wanting to find the person who typed the wrong command and punish them.
We want a scapegoat.
We always want a scapegoat, but the text demands we look at the system instead. The goal is fixing the system, not punishing the individual.
Right, because humans will always make typos. If one typo brings down the whole database, the architecture is the problem, not the human.
Exactly. A team without blameless postmortems just repeats their mistakes in secret. A team with them evolves.
And finally, artifact number 4, the runbook.
The runbook. This is the ultimate antidote to the bus factor. It is a highly prescriptive, step-by-step procedure for executing recurring tasks.
The rule is, if you do it more than 3 times, write a runbook.
Yes. Deploying an environment, rolling back a release. The standard is that any engineer should be able to execute it flawlessly at 3:80 a.m. during an incident without waking up the original author.
This is how you stop being the bottleneck, and eventually, once it's written down perfectly, you can just automate it.
Exactly. So those are the 4: ADRs, PRs, postmortems, and runbooks.
Okay, so having stripped everything down to those 4 simple artifacts, how do we actually apply this blueprint to a modern parallel working team?
This brings us to the final section, Section 5, which looks at module contracts and asymmetric tooling.
The text gives this highly specific blueprint for a 2-person team, using what it calls a shell and module architecture. Let's break down the bounded context and the module contract.
Sure, so a module is basically a bounded context. It encapsulates its own logic independent of the rest of the app. And the module contract is a one-page agreement on exactly what that module exposes to the shell and what the shell guarantees back.
To put it in beginner terms, it feels like hiring 2 contractors to build the house.
Wow.
You have a plumber building the pipes and a carpenter building the custom kitchen cabinets.
Great analogy.
The contract is the actual blueprint denoting the exact 1-inch coordinate on the wall where the pipe has to meet the sink. If they agree on that 1-inch connection before they start building,
They never collide.
they can operate with total autonomy. The carpenter doesn't need to know how the pipes work. But if they don't have that contract, the carpenter builds a cabinet right over the pipe access, and you have a massive conflict.
Right. And in software, the text points out that the schema, the database structure, is the ultimate stable contract.
Because schema drift is dangerous.
Oh, schema drift is the absolute fastest way for 2 people to lose a shared mental model. Changing the schema requires an ADR, always.
Now, this reliance on strict module contracts opens up what I thought was the most surprising part of the text: asymmetric tooling and AI.
This is where it gets really modern.
The text says that one team member using AI LLM tools while the other is traditional hand coding is totally fine. Asymmetric tooling is encouraged.
Yes.
But I immediately had pushback when I read that. Wouldn't differing tools cause absolute chaos in the code base?
And that is the beginner's aha moment right there. The text argues that if you have a strict module contract in place, it actually doesn't matter how the code is generated.
Wait, really?
Really, a module is a black box. The interface is the only thing that matters. The question isn't, how do I force my partner to stop using their AI tool? The question is, how do I produce work my partner is happy to merge?
So quality is the only metric.
Exactly. If the AI-generated code passes the tests, fulfills the contract, and has a good PR description, the reviewer shouldn't care if a human typed it or a machine generated it.
That is so liberating. It regulates itself, which totally aligns with the text's stance on pair programming versus parallel work.
Right. Pair programming 2 people staring at one screen is great for hard debugging or knowledge transfer.
but the text explicitly states it is highly wasteful for routine work in this kind of architecture.
It is an incredibly expensive use of synchronous time. If the module contract is solid, engineers should be trusted to execute their work independently. We don't need to pair program for everything.
It is so freeing to be told not to pair program all the time.
Right.
Okay, so to summarize this whole journey, we've learned that meetings are insanely expensive, human memory is fundamentally flawed, and handoffs are the danger zone.
The three harsh truths.
By utilizing a shared vocabulary, enforcing those painful WIP limits to finish what we start, and relying on just 4 simple artifacts, ADRs, PRs, runbooks, and postmortems.
Don't forget module contracts.
In module contracts, by using those, we can actually eliminate the vibes and get real work done cleanly, asynchronously, and durably.
It is a complete operating system for modern teams. And it leaves us with one final, incredibly provocative thought to mull over, especially building on that acceptance of AI tools we just talked about.
Let's hear it.
So, if the core reason for all these written artifacts, the ADRs, the detailed PRs, the runbooks, if the reason they exist is primarily to compensate for the fact that human memory is terrible.
Right, we write it because we forget.
Exactly. What happens when our engineering teams are increasingly made up of AI agents that literally never forget?
Oh, wow.
Will these artifacts evolve from being just reminders for frail humans into the literal training manuals that program our synthetic teammates?
That is wild to think about.
Are we right now, just by writing good documentation, actually writing the baseline code for our future automated workforce?
That totally reframes documentation from an administrative chore into the literal architecture of the future.
It changes the stakes of every document we draft.
It really does. So the next time you find yourself stuck in a meandering meeting, watching your life evaporate while the vibes bounce around the room, ask yourself, could this have been an ADR?
And if the answer is yes, get writing.
Because you might just be writing the training manual for the future. Thanks for joining us on this deep dive.